Welcome to today's lecture on adding and subtracting fractions with unlike denominators. I'm Drew Collop. In today's lecture, we're going to expand on what we learned last time when we were adding and subtracting fractions with like denominators. Now we're going to look at fractions with unlike denominators. The process is very similar with one additional step. And if you recall last lecture, we reviewed prime factorization, a way to find the lowest common multiple. So today we're going to combine all the techniques we learned in our last lecture and apply it to unlike denominators. Let's go through the process for how we do that. Step number 1, find the lowest common denominator using prime factorization. We learned about that in our last lecture. Step number 2, convert each fraction to its equivalent fraction with the lowest common denominator. So we want to have both fractions to have exactly the same number in the bottom of the fraction. They are like fractions. They have a common denominator. Next, we add the fractions together and simplify where required. Let's try the first one together. Here we can look at the denominators in both of these, and we can see this is not a like fraction. One has a denominator of 5, the other one has a denominator of 10. So what we have to do, we have to find the lowest common denominator. We do that using prime factorization. We write down the numbers we're given, 5 and 10, the numbers in the group. We then break those down into their prime numbers. 5 is a prime number, 10 is 5 times 2. And here you can see 10 is going to be the lowest common denominator. Now perhaps you could have done this in your head, but I want to follow the steps. Remember, you line the numbers up and they come down if they're the same in a column. What we do now is we adjust all of the denominators so they are 10. This fraction already has 10 as a denominator. No need to do anything to it. The next one, though, we have to multiply by a value to make it equal to 10. 5 times 2 is 10. Now remember, we don't want to change the value of this fraction. So to do that, we must multiply the top by exactly the same number. If you do that, the value doesn't change, just how that value is expressed. Let's work that out now. 3 times 2 is 6. 5 times 2 is 10. And this fraction doesn't change. Now we have like fractions. We have a common denominator. So we just follow what we learned last time. The denominator remains the same. And we do the math associated with the numerators. In this case here, 6 plus 3. And this is going to be 9 over 10. Always ask yourself, can we simplify this more? Is there a common whole number that can come out of 9 and come out of 10? The answer is no. So therefore, this is the final answer. Let's try the next one together. Here we have 3 different fractions. We have 8, 4, and 16 as the denominator. So let's find the lowest common denominator by doing prime factorization. Again, we write down those values that we have, the groupings of the denominators, and we break it down to prime numbers. 4 is 2 times 2, 8 is 2 times 2 times 2, and 16 is 2 times 2 times 2 times 2. Once again, if they're common numbers, we line them up, and we only bring one number down. We bring that down, and you can see 16 is the lowest common denominator. Again, hopefully you could do this in your head, but we're going to follow the process. This value is already 16. No need to change it at all. 8, we got to multiply by 2. Multiply the top by 2. 4, we multiply by 4. Multiply the top by 4. Now let's write the next line. 8 times 2 is 16. 7 times 2 is 14. 4 times 4 is 16. 3 times 4 is 12. And this one does not change. So now you can see we have a common denominator in all 3 fractions. Let's combine them by doing the math associated with the numerators. So we have 14 plus 12 plus 1 over 16. Now there's no need to actually do this step. I'm just trying to show you exactly what's going on, not skipping any steps along the way. Combine them now. 14 plus 12 is 26. And then 26 plus 1 is 27. 27 over 16. Now this number cannot be simplified any further, but we can convert it to a mixed number. How many times does 16 go into 27? It goes in one time. How much do we have left over there? 27, we have 11 remaining, right? 11 plus 16 is 27. So if we want to, we can express that as a mixed number of 1 and 11/16. I'd like you to pause the video now and attempt to solve the next one on your own using the methods we've learned today. Give that a try now. Okay, let's take it up then. Prime factorization. We have 5, we have 8, we have 20. 5 is a prime number. 8, 2 times 2 times 2. And I make sure I don't line up the 5 with the 2 because those are different numbers. 20 here, what is that? That's going to be 5 times 2 times 2, right? 10 times 2. We can see there's a lot of commonality between those three numbers. Remember, any numbers that repeat, we put them in the same column. Numbers that are unique, we put them on their own. We bring down those numbers now. We then do the math. That's 10, that's 4. 40 is our lowest common denominator. So let's work this out. 5 times 8 is 40. 2 times 8 has to be done to not change the value at all. 8 times 5 is 40. Do the same to the top times 5. And 20 times 2 is 40. Do the same to the top. We'll then do the math now. 2 times 8 is 16 over 40. 3 times 5 is 15 over 40. And 2 times 7 is 14 over 40. Now you can see we have a common denominator. We're going to put them all together over the same common denominator. And here we get 16 plus 14 is 30 plus 15 is 45. Ask yourself now, is this in simplest terms? No, it's not. I can see a 5 can come out of the top and a 5 can come out of the bottom. When we do that, we get 9 over 8. Now, this fraction is in simplest terms, but again, it is an improper fraction. The numerator is larger than the denominator. So what we can do is convert that to a mixed number. And here we have 1 and 1/8, final answer. So hopefully you can see, last lecture we learned many different techniques. We learned about adding fractions and subtracting fractions with like denominators. We learned about prime factorization, and we learned about comparing fractions and converting so we can have a common denominator. We're now taking all those skills we learned, we're applying them all at the same time. Last day we talked about a word problem. Let's work through another word problem very similar to last day. So step number 1, read carefully. A student weighed 2/15 of a gram of HCl in a dish, which weighed 7/11 of a gram. What was the total weight? So student weighed HCl in a dish, and the dish appeared to weigh this much. What was the total weight? So I'm given two pieces of information. They're being weighed together, so it must be addition. And I'm asked what the total weight is. I'm adding up the two masses. Let's write that equation now. 2 over 15. I'm going to write the units in, and then 7 over 11 grams. I'm leaving some space because I know that these are not like fractions, and I'll have to find a common denominator. Let's do that now. 11 and 15. 11 is a prime number. 15 is 5 times 3. 11 times 5 times 3. And in the end, here we get 165, a very large number. What we can do here, we can multiply the top and the bottom by 11 to get 165. Over here, multiply the top and the bottom by 15. Once again, you could just say, well, sir, we just multiplied the two denominators together. If you multiply the two denominators together, you will always get a common denominator. However, it won't always be the lowest common denominator. Prime factorization will always give you the lowest common denominator. So just be aware of that. Let's do the math now. 2 times 11 is 22 over 165. Here, 7 times 15 is 105 over 165 grams now. Again, double check. Is it the same units? We can add these up only if they're the same units. They're both in grams, so therefore we can add them directly. We're adding two fractions with the same denominator. 165 grams is going to be the units, and here we do 22 plus 105. Again, you can skip this step. I just want to show you exactly what we're doing. 22 plus 105, 127 over 165 grams. Now ask yourself, can that be simplified any further? Is there a common number between 127 and 165? There is not. That is the final answer. However, we're not quite done. Therefore, the total mass, I guess I shouldn't say mass, I should say weight, because that's what it was asked for in the original problem, was 127 over 165 grams. Does that seem reasonable? We're taking a very small number, 22 over 165, and we're adding to it 105 over 165. Both numbers that are less than 1 whole. And you can see this is still a small number. And we asked for total weight. We reported total weight. Always double check that. Next problem. This looks like an electricity problem. A circuit wired in parallel with 3 resistors has the following equation. So you can see this equation is actually a fraction. We have 1 over the total resistance equals 1 over the resistance of the first one, plus 1 over the resistance of the second one, plus 1 over resistance of the third one. And here we've defined what some of these variables are. R1 is 5 ohms. That is what the symbol for ohms looks like. It's the Greek letter omega. R2 is 10 ohms, and R3 is 20 ohms. What is the R total? Don't worry if you don't understand how this applies to science. Don't worry if you don't understand the units. All you have to worry about is plugging these values in and getting the right answer. So I'll help you with that right now. So this is a formula we've been given. This formula is a well-known scientific formula. And you can see here, R1 is this. R2 is this one, and R3 is this one. So what we're going to do, we're going to substitute. Hopefully you already know this, but we're going to go through every step to make sure no one gets left behind. So what I'm going to do, you can see here, I've said that R1 is equal to 5 ohms. So what I'm going to do, I'm going to substitute it. I'm going to erase the R1. I'm going to put in 5 ohms on the bottom there. R2 says it's 10 ohms, so I'm going to erase R2. I'm going to substitute it with 10 ohms. Lastly, R3 is 20 ohms, so I remove the R3 and I substitute the R3 for what it is equal to, 20 ohms. Now be careful. Many a student has done this. Oh, sir, this is easy. I know this one. This is going to be 1 over 35 ohms. Wrong. What that student did, they saw this problem and they just did, well, that's going to be 5 plus 10 plus 20. Don't do it that way. That's wrong. What we do is we find a common denominator. When we get that, the denominator remains the same and we do the math to the numerators. Don't worry about the units for now. Let's worry about the numbers. So we have 5, 10, and 20 as denominators. We need to find a common denominator. So we're going to do prime factorization. We are going to break down these denominators into their prime numbers. 5 times 2 is 10. 5 times 2 is 20. You can see we've put these in columns. And we have 5 times 2 times 2, and that is equal to 20. First one remains the same. It's already as 20. This one, let's multiply by 2, multiply the top by 2, multiply by 4, multiply by 4. So now we get 1 over R total is equal to 4 over 20 ohms plus 2 over 20 ohms plus 1 over 20 ohms. Now we add those fractions together now that we have a common denominator. Common denominator is 20 ohms, and here 4 plus 2 plus 1 is 7. Ask yourself, can I simplify that down anymore? Can I simplify 7 over 20? I cannot. Is that our final answer? Be careful. Remember what I said earlier. Always look what the question's asking you for. What is our total? Well, this here is not our total. This here is 1 over our total. So what we have to do, we have to take the reciprocal. If I flip this over, this becomes our total over 1. And if I do that, I have to do the same here. 20 ohms over 7. You can see this is what I asked for. This is what we're getting here. Therefore, the R total, the total resistance, is equal to 20 over 7, and its ohms is the units. Always double check that. Many times there's one additional step you have to do. Make sure you don't miss that. Easy way to lose marks. So that was adding unlike fractions. Now let's apply that same process to subtracting unlike fractions. It's exactly the same, except instead of adding the numerators, now we do the subtraction where applicable. So let's look at the first one, 9 and 11. Here we have 9 and 11. We're going to do prime factorization, 3 times 3. And 11 is its own prime number, 3 times 3 times 11. And here we get 99 as our lowest common denominator. Multiply this side by 9, multiply this side by 11. Here we get 77 over 99 minus 3 times 9 is 27 over 99. Now we have common denominators. Now we write that down on the next line. The denominator does not change. It remains the same. And we apply the math to the numerators. So here we're having 77 minus 27. 77 minus 27 is 50 over 99. Ask yourself, can I pull out a common factor from 50 or 99? I cannot. Therefore, this is the final answer. Here we have 3 fractions, each with a different denominator. Prime factorization, 4, 8, 16. 2 times 2, 2 times 2 times 2, and 2 times 2 times 2 times 2. Line them up. If they're common terms, only bring 1 down. 2 times 2 times 2 times 2 equals 16. So here, times 2 times 2 times 4 times 4. In this case, I want to make sure all the denominators become 16. Find whatever number you have to multiply to get it to that value. And whatever you do to the bottom of that particular fraction, make sure you do the same thing to the top. So here we have 15 over 16 minus 3 times 2 is 6 over 16 minus 4 times 1 over 16. Here we have a common denominator of 16. And then we look at the math here. 15 minus 6 minus 4. Let's write that down. 15 minus 6 minus 4. Make sure that encompasses the whole thing. 15 minus 6 is going to be 9. Minus 4 is going to be 5. 5 over 16. Can we simplify this down anymore? We cannot. 5 over 16 is the final answer. Here we have another word problem. Before chemotherapy, so this is chemical treatment of some sort of cancer, a patient's tumor has a mass of 5/7 of a kilogram. After each week of treatment, the tumor's mass was reduced by 1/8 of a kilogram. What was the mass after 4 weeks? So be careful of this one. We have to start working through this and trying to figure out there's an extra step here. So let's read it carefully. Before chemotherapy, the mass of the tumor was this much. After each week, the mass was reduced by 1/8 of a kilogram. Reduced, that means subtracted. What was the mass after 4 weeks? 4 weeks. So be careful with that. Each week it was reduced by that much. So we have to do an extra step here. What we must do now is we must combine all those weeks of tumor shrinkage by 1/8 of a kilogram. So here, the first week, it shrunk by 1/8 of a kilogram. The second week, it shrunk by 1/8 of a kilogram. The third week, it shrunk by 1/8 of a kilogram. And the fourth week, it shrunk by 1/8 of a kilogram. First of all, we can add them all together because they all have the same units of kilograms. They also are all like fractions, so there's no need to adjust the denominator. 8 is going to be our denominator. Kilograms is going to be our units. 1 plus 1 plus 1 plus 1 is 4. We can simplify this down. Take a 4 out of the top and out of the bottom, and here we get 1/2 kilogram. Now be careful. The question asks, what was the mass after 4 weeks? Not how much mass was lost after 4 weeks. How much mass was remaining? So here we have to build that formula. The initial mass was 5 over 7 kilograms, and after 4 weeks, we're losing half a kilogram. What is the answer to this? Well, here, we'll do some prime factorization. 2 and 7. 2, 7, both prime numbers. Lowest common denominator here is going to be 14. Times 2 times 2 times 7 times 7. Here we get 10 over 14 kilograms, and then we're subtracting 1 times 7 is 7 over 14 kilograms. This is a good thing. If you're going in for treatment on cancer, you want that tumor to shrink. We then put this over a common denominator of 14. Units is going to be kilograms, and then we look at the math we have to do here. 10 minus 7. 10 minus 7 is 3. Ask yourself, can that be simplified any further? It cannot. So we write the concluding statement. Therefore, the mass of the tumor was 3/14 of a kilogram after 4 weeks of treatment. Double check. Is that what we were asked to find out? Yes, what the mass was after 4 weeks of treatment. So hopefully you have a strong understanding of how we bring all those skills together. The skills of adding and subtracting fractions with like denominators, those skills for finding the lowest common denominator, and the skills for creating denominators of the same value. Let's try some practice problems. So I'm going to ask you to pause your video now and give these a try. There's a number of them. It's going to take you some time, but I'd like you to try them all on your own right now. Here we have A to E, and then we have F to J. So pause your video on either of these frames and try and solve these on your own. And I'll take up ones that look like they're a challenge. So here's your answers for the first batch, and here's your answers for the second batch. Hopefully you got them all right. I'm not going to take them all up. If there's some you want me to take up that I don't today, please do email me and we can work through that during tutorial. Now please note, if you just wrote this answer as one of my assessments, you're not going to pass that assessment. I need to see the work you're doing. So let's go through and take up some of these ones that I think might be more challenging. I think A through D are pretty simple, so we're just going to skip right over those. Let's take up some of these now. Let's take up E. So lowest common denominator between 3, 4, and 12 is going to be 12. If you want me to double check that, 3, 4, and 12. 3, 2 times 2. 3 times 2 times 2, 3 times 2 times 2 equals 12. So here, times 3 times 3 times 4 times 4. We then do the math. 4 over 12 minus 9 over 12 plus 8 over 12. Combine those together. We get 4 minus 9 plus 8 over 12. In the end here, we get 4 minus 9 is going to be minus 5. Let's write that down. And then we get minus 5 plus 8, going to be positive 3 over 12. We can simplify that down. Take a 3 out of the top and the bottom. And here we get 1 over 4. Answer to this one is 1/4. Let's try F together. Now, here we have denominators of 16, 8, and 4. And I've already done prime factorization on this earlier in the video. So we know that the lowest common denominator is going to be 16. If you want proof of that, go back and watch the section in the video on this. Here then, 3 times 2 is 6 over 16 plus 1 over 16 minus 12 over 16. We then combine those together. 6 plus 1 minus 12 over 16. This is going to be 6 plus 1, which is 7. 7 minus 12 is minus 5 over 16. Can we simplify any further? We cannot. That is the final answer. Let's try the next one. Minus 8 over 4 plus 9 over 3 minus 25 over 5. There's a trick to this one. We don't actually have to do prime factorization. Look at those fractions right now. What do you see? What's 8 over 4? What's 9 over 3? What's 25 over 5? These are whole numbers. So you can see sometimes if you notice something unique, you can save yourself a lot of hassle. Alternatively, your lowest common denominator would have been 60, and you could have worked it out from there. I think H is pretty self-explanatory. What do we have here now? I and J. Let's take those both up. What do we have here now? We have 4, 7, and 14. Let's find the lowest common denominator by doing prime factorization. 4, 7, and 14. 2 times 2. 7 is its own prime number, and 14 is 2 times 7. So here we line up those 2's, we line up these 7's, and this 2 is on its own. 2 times 2 times 7, which is 4 times 7, which is 28, is your lowest common denominator. So here to get 4 equal to 28, must multiply by 7. To get 7 equal to 28, must multiply by 4. And 14 to be 28 is multiplied by 2. We work that out now. Minus 21 over 28 plus 4 over 28 minus 4 over 28. Combine them together now. Common factor of 28. And here we got minus 21 plus 4 minus 4 over 28. Minus 21 plus 4 is going to be minus 17 minus 4. And then minus 17 minus 4 is minus 21. Can we simplify this down any further? Yes, we can. I can pull a 7 out of the top, and I can pull a 7 out of the bottom. And here we get minus 3 over 4. Last question for today's lecture. Here we have something we haven't worked with before yet. We have a whole number. How do we work with that? Remember, we can turn any whole number into a fraction by placing it over top of a denominator of 1. Let's figure out what the lowest common denominator is between 1, 4, and 6. Well, 1 is its own prime number, doesn't change anything. 2 times 2, 2 times 3. We line these up. 1, 2, 2, and 3. Here we have 12. 12 is my lowest common denominator. So we all want to have a denominator of 12 in these. 6 times 2, 5 times 2. 4 times 3, 3 times 3. Times 12, do the same to the top. Here we now have minus 10 over 12, minus 9 over 12, plus 12 over 12. Common denominator is 12 here now. Minus 10, minus 9, plus 12. Minus 10 minus 9, minus 19 plus 12 over 12. Now be careful here. Some of you might make a mistake here if you're not paying attention. You might say, oh, this is easy, sir. These cancel out. Wrong. We can't cancel values out if they're added or subtracted. This here does not have a 12 in it. Therefore, we cannot take a 12 out of the bottom. What we have to do now, minus 19 plus 12 is minus 7 over 12. Can we pull out a common factor here from the top and the bottom? We cannot. Therefore, the final answer is negative 7 over 12. In today's lecture, we took all the skills we learned in lecture number 7, the skills of adding and subtracting fractions with a like denominator, the same denominator. We took the skills of prime factorization to find the lowest common denominator, and we took the skills of converting a denominator on a fraction into something else by multiplying the same number on the top as we do on the bottom. That's all for today. Until next time.